So we have a rectangular tank with a square base and an open top. So this is open here. Square base, so we'll call the base x and x, and the height we'll call h. We're given the volume to be 12,800 feet cubed. And the material for the base costs $4 per square foot. And for the sides, costs $10 per square foot. Find the dimensions of the tank that minimize the cost of the materials for the tank. Okay, so we need to come up with an equation for the volume, since we have the volume as 12,800. So that's the length times the width times the height. And we want to come up with a cost equation. We'll call it C. So first, let's look at the base. There's only one base. The top one is open. So we have the bottom here. The area of that is x squared. And that's x squared feet squared. So we need to multiply by 4 to get the cost of the base. Now, for the sides, we have 4 sides. And we want to multiply the area of the sides by 10 to get the amount. So there's 4 of them, and then each area is going to be x times h. So it's going to be 4xh. So simplifying this, we get 4x squared plus 40xh. Now I can solve for h here and get 12,800 over x squared. So that's going to go in for h. So now this formula only depends on x. Okay, so it's 4x squared plus one of the x is going to cancel, and then a good way to do this is do 128 times 4. That's the same thing as doing 128 times 2, which is 512, and then there's going to be 3 zeros afterwards. Now we want to minimize this cost, so let's take the derivative and set it equal to 0. The goal is to solve for x, so let's add both sides by 512,000, or yeah, this is supposed to be a 0 here. So 512,000 over x squared. Cross multiply. And now we need to divide both sides by 8 to get x cubed is 64,000. Taking the cube root, we get 40. So this is 40 feet. If x is 40 feet, that means we need to solve for h. If I plug it into that equation, so h is 12,800 divided by x squared, which is 40 squared. Okay, so that's 12,800 over 1,600. So you can cancel out the zeros. Let's say 128 over 16. This is basically 2 to the 7th over 2 to the 4th. So you know this is going to be 2 cubed, which is 8. Okay. So the height has to be 8. So the dimensions that minimize the cost are 40 feet by 40 feet by 8 feet. Now we want to see what the minimum cost actually is. So we can either plug it into this equation up here. Actually, any of these equations down here. So I'm just going to keep it simple and plug it into the equation that only depends on x. So I'm going to plug it into this one. So x we said is 40. So you have 4 times 40 squared plus 512,000 over 40. So 4 squared is 16 times 4 is 64, and that's going to be 2 zeros. And for this one of the zeros is going to cancel. 512 divided by 4, that's going to be 128, and then followed by 2 zeros. So it's 12,800 and 6,400, so this will be, let's see, 12 plus 6 is 18, and then we carry over. That's $19,200. And that's our answer.